Hello everyone. In this session, we'll be discussing the basic processing unit in Unit 3, and in that we'll see how instruction gets executed. So the first step in instruction execution is to fetch the instruction from the memory. So instruction is a program and is stored in successive memory locations until so all these instructions should be fetched from memory from successive memory locations, and it will get executed until you have a jump or a branch instruction. So to keep track of the address of the memory where the current instruction is located, that is getting executed is located, you have a special register called program counter, which will keep track of the address of the next instruction to be executed. So during execution, after fetching and during execution of the instruction, the program counter should be updated so that it points to the next instruction that should be executed. And when it encounters during execution, when it encounters a branch instruction, that instruction will update the program counter with the new target address. So we'll see what happens in the fetch phase. So PC is the program counter. The contents of the program counter will give you the address, and you have to read the contents of that address and will be loaded into the instruction register. Now, once it is loaded into the instruction register, it will start executing, and meanwhile, you have to update the program counter. So, program counter will be incremented by 4. We are assuming that we have 4 bytes for every instruction. Now, we will see how we can break down the implementation and execution of instructions into various stages, so that each of the stage is performed by a different subcircuit. And you can uh, for every stage you can have a part of the instruction that gets executed, and you will need n stages to complete an instruction execution. So since we are dividing the in each instruction execution into n stages, the amount of time required to per clock period will shorten. So if we need 10 nanoseconds to execute an instruction, since we are dividing it into stages, each stage, and if we have 5 stages, each stage will take only 2 nanoseconds. So we can have a clock period of 2 nanoseconds instead of having 10 nanoseconds. So this will greatly reduce the clock period. And the multi-stage structure is suitable for pipelined operation. So this is an example pipeline processing or a multi-stage stage where it is divided into 3 stages. So for stage 1 you have the logic circuit, stage 3, 2 and 3. In between these stages you have the buffer registers. So you give the store the input to the register to the circuit in registers, and the circuit calculates and the output is stored in the output register. Stage 2 takes the input from the buffer register. Likewise, it goes. So, pipeline processors, we use multi-stage processing. So, it improves the efficiency of the processor. So, now we will see for different instructions how we can divide the execution steps. So always the first step will be to fetch the instruction from memory, and the next step will be to increment the program counter. The third step will be to decode what that instruction is and to determine the operation to be performed. Then the next step will be to read the source operands given in the instruction. So now here you can see the value of x is an immediate value. So once the source operand registers are read, so in this case R7 is the source register. Then you can read the x value which is in the instruction itself. Then you can add the contents of R7 and x. And this x plus R7 will be the address, effective address, which is calculated, and you have to read the contents from the memory. So memory read operation will happen. So effective address calculation, and after effective address calculation, memory read operation happens. So memory read operation happens and it is loaded into the register R5. So if we divide it into 5 stages, first instruction fetch and increment the program counter. Second step is to decode the instruction and read the contents of the source register R7. Then compute the effective address, that is adding x plus R7. Then read the memory source operand. Then load the operand into destination register R5. So we have divided it into 5 steps. Same way, if we see for the add instruction, first fetch the instruction and increment the program counter, then decode the instruction and read the source operands R4 and R5. Then the third step will be to actually calculate or execute, that is add R4 plus R5. Then the fourth step will be to save the register result into the register R3. Here in the memory read or write operation is not needed. So only 4 steps. So if we want to represent in 5 steps, the fourth step will be no action. Now we'll see for the store instruction. So for store, again fetch the instruction and increment the program counter will be the first step. Then decode the instruction and read the source operand. Here the source operand will be R6 and R8. Now you have to calculate the effective address for the memory operand. So third step will be calculating the effective address, which is x plus R8. Then the fifth step will be to write the memory. So from the register R6, it has to be written into the memory location x plus R8. And then finally, in the fifth step, there is no action. So here also 4 steps, but if we generalize, the fifth step is no action. So in summary, for all types of instruction, whether it is load, store, or an arithmetic instruction, the first step will be fetching the instruction and increment the program counter, then decode the instructions and read the registers, then perform the arithmetic operation. Then the fourth step will be read or write the data from or into memory, and the fifth step is to write the result into the destination register. Thank you.